today we will be looking at entropy, how to use entropy in Python. And if you already have physics background, you already know that entropy gives you a measure of disorderliness in a certain system. And so for image processing, for instance, if you have an image there, it's smooth on one side, or some features are smooth and the other features are really rough, then you could use this entropy to prepare such images for thresholding. So suppose you want to extract or identify features in those images that are really rough, then you could use something like entropy, and it's able to like separate the smooth from the rough basically. I'll be showing you an example, but I just wanted to give you some little background. And this has been used in other fields such as in information theory, or where this particular phenomenon takes a log base 2 of a number of possible outcome messages. That's not important. Let's just go straight into coding. Once you see example here, it will be more clear. And so the first is, as usual in Python, you have to import the packages. I don't want to be typing on the screen, so I have this copied somewhere from scikit image. And so we need the matplotlib for plotting. So it's just the pyplot. We import this as plt, which is a typical way of doing it. Of course, you could use any other stuff. We need the numpy to manipulate the arrays, and so we import that as np. And this is all coming from scikit image, which is the provider of this example that I'm going to use in this particular video. We import the scikit image data, which is the data they provide, the example data they provide that you could use. So we'll be using open source data provided by scikit image, but in the last one I will use my own image actually and test the code on it to see how it performs. And we also use the image as ubyte, which is just a way of converting the image type from float to unsigned digit 8, and this is in the scikit image utils. And then we'll go to the filters, which is what we're talking about in this particular tutorial. From filters in scikit image, we'll go into rank and import entropy. And so entropy needs a disk, and so we'll also import from scikit morphology a disk. And this could be square, or it could be cycle, or it could be whatever. Or you could even customize your disk. I'll do another tutorial showing you how to make disk actually. And so let's go into object detection. So suppose you have an object. In this case, we'll do a mask that would be ones and zeros only. And then we'll create some noise and then combine the two images together so that we'll have a noisy image. And if I plot this, you would see the noise will overshadow the object, so you'll not be able to see the object, but you will see the noise just because of the magnitude that we give to the noise. Okay, and then we'll apply the entropy, or we'll create an entropy image and plot 3 of them, and then you will better appreciate what this does. And then we'll move further in this next one to demonstrate how you could apply this to day-to-day applications, by example using the image I took on you on every point. Great. And so I wouldn't be doing too much typing today. I will go somewhere and grab a code, and then I'll explain to you what the code is doing, and then from there we'll just proceed. I'm just trying to make the video to be really short. And so here we import the random. So it's in the random. It just allows us to generate random numbers basically, but in this case we've been generating it in 2D, which I will show you just in a bit. And let's clean it up a bit. And if we have our image size, we could create something called image size or image shape or whatever. Image size is equal to, let's create a tuple that will have the height of the image and the width of the image. And this one, let's just give it a value of say 128, so that will save space. It's usually good to have maybe smaller image, and so 128 by 128, and then we use this image height and image width to create a tuple there of what we are calling the image size. Okay, and then we could use this image size in creating a full, and then we could give it some values for that particular intensity, and then we could give it a type. In this case, we're going with unsigned integer 8, which is typically integers, or yeah, way of mostly how the image usually appear. And so next we could choose to plot this. Now if we plot this, is just you just have these values and the image will be of this size. But we could also do something more complete by picking up this max that we generated that will have all zeros or near to zero, since the value is too small compared to like 255. And then we would select a portion of that image. In this case, we're selecting from pixel 32 and 32 and 32 to towards the last 32, and then we'll give it a value of 30. And once we have this value is also small compared to 255, which is a maximum for this unsigned integer 8 image. Of course, you could also make this neater by writing something like, say, pixel index is equal to, say, 32. So that will be our pixel index is equal to that 32, and then we could replace all these numbers so that we don't, if we want to change something, we don't have to type over and over again. And so this is just giving the boundary of that particular object that we want to create in this particular image. And then we give it a value, so some value there. And value is 30. You could also assign that to something and then play with it and see how that will change. Now if we increase the number, what happens, for example. And then next we'll create a noise for this particular image. So now we have an object, which an image that we call it an object is just a mask. It has low and high values. And then we will do the noise, and the noise we just need this noise mask, and then we use these randoms that will help us generate random numbers. And then here we just do some little amplitude on the noise, on the mask values. We just scale it by half, and then we just change the type to match whatever we had here before, so they're in the same space basically. And then we could now call the main image, that will be this noise, to be this noise that we generated here, which would just be random numbers of particular shape of the image mask. And then we added 128 such that the noise is more powerful than the main image. Remember, the main image we were using the value of this one, and now we have and then the background was this value, but in the section middle it was slightly above the brightness of the background by 2, value 2 intensity. And so next is we add this noise by 128. Remember, the max value that we have in this image is 255, and so we're going very close to, or we've even passed the half of the overall brightness that we have in that image. And so this will be a noisy image basically. And then in the next step we'll calculate the entropy for that particular image using just the entropy, which we imported here. And then we'll provide in our image utility. First input is your image, which will be the raw image you want to work on, and then a disk, and you provide the size of the disk. In this case, we're giving it a disk that will be a 10 by 10 pixel, and this is a disk, and so this will be by default to be a square disk. Yep, I don't want to bother you too much information, but that's that. And so if you have this now, if we run this shouldn't complain. numpy.mp is not defined. It's because we did not run the first cell. So we'll run that, and then we'll run this again, and that shouldn't complain. And next we'll now visualize what we coded here. And so I'll change that to a markdown. And if I run that and create a new cell below, I'm just typing a B for below, and then I already have the plotting command here, and so I'll just copy it and then paste it here. The variables names are the same, so I just paste and run issue sort of stuff. And so what we're doing here is basically we're using a subplot in matplotlib, and here we're just giving it a fig. This is just a handle that will allow us to manipulate the overall subplots together. So if we want to save this fig, we could just use fig.save. And then we also have the axis. In this case, we're doing a subplot of 3 panels, and so we have the different panels with different axes so that we could manipulate individual axes basically. And so we have 0 to 2. And then in the subplot itself, we're providing a number of rows we need just a single row, but we need how many columns? 3. So this is just think of horizontal with picture, picture, picture. Okay, and then we could provide a figure size 10,4. This is the horizontal and this is the vertical. Okay, and then the next one, we just use the image plotting command in matplotlib called imshow. And so on the first axis, we'll be plotting the noisy mask, which is just this first stuff that we created here. That will just be an object. We'll have zeros, or zeros and not really zeros, but little values and little high values. So you could see clearly in that. That one will be black, more black, and we're using the gray as a color map. And this one we're calling object, or we could call this original. And then in the second panel, which is the axis 2, which is using an imshow, and we're plotting the image. In this case, it's the noisy image. Remember, we'll scale this noise up by 0.5, and then added another intensity value of 128 to it. And this is going to be the noisy image. This is really the noise, which will introduce a disorderliness that we want to clean and be able to identify the boundary from this main mask. And so the last one would be the entropy itself. After entropy has been applied to this particular noisy image of this particular disk size, you could play with changing this and see what happens. The code will be available on my GitHub in this particular name. So if we go to my PyCourse, that will be there. And so this one will be the local entropy, and we could change this to maybe a jet color or red, blue, jet. Let's use jet. And then if we run this now, there we go. And so this was the main object we created. Remember, it was 128 by 128 pixels, and this is the noise. So this is pure noise. So this is the input that we're actually giving the entropy, and it's able to a great extent identify this object, which was even slightly above by the background with a value of just 2 intensity. And we could, to a great extent, see the shape of that particular object that we introduced there. So it goes from 25 to 125 and there to that. So that's how this entropy works. And so with this, if you have an image that's like this, that has some information in the background, that has that has some background and has some other stuff, then you could use it to a great extent, estimate what is actually there. And so if you identify the corners and you measure these corners straight, then you could, to a great extent, recover this particular object. Hope that makes sense. The code will be available again. And so let's go to the last one. The last one, also I have the code here. So I'll just run this. This one is just using from this one is more practical. This is like an image of someone taking a picture. So it's a cameraman, and we're getting this from on the scikit image data. So it has data, which comes with the package. If you install the package, you already have the data on your computer, and it's called camera. And so we just fetch this image, and after this I'll test it with my own image that I took myself, just to see how it performs. And again, everything here is what I explained above. Just like in this case, we have only 2 panels, and so directly we're applying the entropy on the image that we loaded here, and of thick size 5. And then the color map here, we could use any other stuff. We could use a spectra, maybe a reverse spectra, and this is the local entropy. Let's just call that local entropy. And this is the original image, original image. And then if we plot this now, that's how it looks. We could, to a very great extent, see the edges of this object, and now we could begin to properly. Like, remember we had this lot of peppery noise, but with this we could come up with the threshold value that will actually eliminate the background. Like, this part was really smooth, some details showed up, but still we could be able to like track those images. And you could also change this size to maybe 15, run it, and then you can see how it changes. So it blurs out a little more. What if you change it to 10, which is twice what it had before? This is how it would look like. And so you could begin to increase the contrast at this point, and you could use some thresholding to be able to like bring out this guy neatly out of this particular image. So that's how Entropy works. Hope this is useful. But before I go, remember I promised I would load my own image and give an example. So for me, I would do an import CV2. I would use CV2 for my own. Maybe I don't have CV2 in that. Okay, I do have. So I could do cv2.imread, which is a way of reading image. And my image is at this place. At this place in the data folder. And it's called Yukon every point.jpg. Close that. Let's call this my image. I just call that one since I have image in there. If I run that, it has loaded that. So the image is in this particular folder, and that's the name. That's how I got that name. And so once we have this, then we'll apply the entropy, which is just this way. I just copy this, and I just call this entropy 1, so I don't waste much of your time on image 1. So don't override that one, and then we'll have that, and then we're using a disk size of 10. Maybe that will be too much. Let's just start with the 5. And then let's plot using this command. And so I just need to change this to be this guy here. So since I applied outside already, I don't need this guy to be here again. So we'll delete that. And we could use any other color map. Let's try a gray now, since we haven't used gray much. And in reading this image, I want to read it just as a gray scale image, and so I'll put a 0 there. And that's the original. Let's change this to be our image 1, which is that name, and then this one is what we're showing here. And I think that's good to go. Color bound image 1. If I run this now, complained about the CMap here in my I said gray. It don't like that. That's crazy. On the image 1. Yeah, for now let's silent that and run that. CMap, that's really strange. Okay, this I'm using here. Image 1. Let's just change this guy to it to be equal to, let's do gray for both of them. So that was the raw image, and it's complaining about the second CMap. Color by the fig. I silent that. Oh, this is the image 1, so it's actually buggy. Let's silent that. Entropy image 1. It's not defined, so we need to run that and then run that. Okay, so it will load that and do those plotting. Yeah, so the issue was coming from, I did not run this after I changed it to some grayscale. So it was like a color image, so it had 3 channels, and then I was trying to do some weird stuff. And then, so yeah, so you could see how this is able to like come up with this clean line that we could separate the sky from these other gravels that are here. And then you will even see more details here with those clouds forming those lines there. So that's how entropy works. Hopefully this is helpful. You can also increase the kernel size if you're curious of what it does to maybe 15. And if I run that, will take forever. And then run that, and then that's where we'll end the video. Please drop in a comment if there is anything that you want me to make a video about, and I will be happy to do that. Thanks, and please subscribe because I'll be dropping videos every day. And if you follow this through, you should be very good in Python image processing most specifically. And so that's how the final result looks like. Thanks again. See you in my next video. Bye.